Hello everyone, welcome to our review of Chapter 7. We'll be spending a little bit of time on all of this because there was a lot of stuff to go over, and then we'll have a test after the review. So the first one we're going to talk about is 7.1, and that was solving our linear systems by graphing. So if we take our equations, I'll say this is equation 1, and then this is equation 2. Equation 1, if we are going to solve that by graphing, we should write that out so we can get y by itself. So I'm going to subtract x from both sides. We get negative y equals negative x plus 9 divided by negative 1. And y equals x minus 9. So our first equation, our first line is going to start at negative 9, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to go up 1 and over 1. So we could create a line that's going from here all the way up through here. Then our second line is 3x plus 2y equals 2. So we're going to subtract 3x. And we get 2y equals a negative 3x plus 2. We divide that by 2. And we get y equals a negative 3 over 2x plus 1. So this line we begin at positive 1. Now it says to go down negative 3 and over 2, so we'll go down 1, 2, 3 and over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Oh, one more. Now we could create a line from those. Now where our points cross, that's where our solution is to this system. So it looks to me like they cross here, and that point is over 1, 2, 3, and down 1, 2, 3, 4, 5. So our solution is 3, negative 5. Alright, again, we have another one that we're solving by graphing. So we have equation 1, and we have equation 2. So equation 1, we have negative 3x minus y equals a negative 1. We'll start by adding 3x. So we have negative y equals 3x minus 1. Divide by negative 1. And y equals a negative 3x plus 1. So we begin at positive 1. We go up 1, 2, 3 and over 1. Up 1, 2, 3 over 1. Until we can draw our line. Second line, we're going to take 2x plus 4y equals a negative 16. And subtract the 2x. And we get 4y equals negative 2x minus 16. We divide by 4. We'll get y equals a negative 1/2 x minus 4. So we begin that at negative 4, negative 1, 2, 3, 4. This one we're going down 1 and over 2. So we can create our line then. Now if we make this line straighter, our solution looks to be right here in the middle. And that looks to be about negative 1.5 and about negative 1, 2, 3.5. So our solution is negative 1.5, negative 3.5. Next, 7.2, solve this by substitution. So I see that we have a y by itself. This y equals something else. So I'm going to take what the y equals, the 2x minus 7, and I'm going to plug that in or substitute it for our y. So we have x plus 2 now times 2x minus 7 equals 1. So that gives us x plus 4x. When we distribute the 2, minus 14 equals 1. X plus 4x gives us 5x. Here we have to add 14. And we get 5x equals 15. Then if we divide that by 5, we're left with x equals 3. So we need to have both an x and a y for this system. We know our x is 5, but we don't know what our y is yet. So we need to plug our 3 back into one of our equations. I'm going to plug it back into this equation because I already have y solved. So we'll have y equals 2 times 5. Well, not 5, it's 3. So 2 times 3 minus 7. 2 times 3 is 6. 6 minus 7 is negative 1. So y equals a negative 1. Here we don't have a variable by itself, so we need to get one all by itself. I'm going to take this second equation, I'm going to try to get x by itself. So I'm going to move the y over. So I'm going to add y to both sides. And what we're left with is x equals y plus 4. So now we can take that y plus 4 and we can substitute it in for our x. So our new equation then would be y plus 4 plus 4y equals 9. If we do y and 4y, we get 5y plus 4 equals 9. Then we subtract 4, and 5y equals 5. Then divide that by 5, and we get y equals 1. So now we can take that 1 and we can plug it in for our y. So we'll have x equals 1 plus 4, which means x equals 5. So our solution then would be 5, 1. Next, we're solving the system using elimination. So when we're trying to solve using elimination, we're trying to get our x's and our y's lined up. So here our x's and our y's aren't lined up because our equal signs aren't lined up. So I'm going to subtract this y to move it over to the other side. So we get 3x minus y equals 1. So now we need to either add or subtract to eliminate one of these. Now I can't add or subtract anything from 2 and 3 to eliminate them, but I could subtract, negative y minus y, which would eliminate our y's. So now we have 2x minus 3x, which gives us a negative 1x, equals 9 minus 1, which is 8. So if we divide that by negative 1, our x equals a negative 8. So now we got to take this negative 8 and plug it back into one of our equations. Our x is negative 8. We need to find what y is. So I'm going to plug it into this equation right here. So we have 2x minus y equals 9. But instead of this x, instead of this 2x, we'll have 2 times a negative 8. 2 times negative 8 gives us negative 16, minus y equals 9. We add 16, we get negative y equals 9 plus 16, which is 25. Divide by negative 1, and y equals a negative 25. So our solution then is negative 8, negative 25. Here it looks like we have two 7y's. So what we can do is we can subtract these two systems to get rid of the y's. X minus a negative 2x, well, those two become positive. So that becomes 3x. 7 minus 7 eliminates. And 12 minus 18 gives us a negative 6. Then we divide by 3, and x equals a negative 2. So what we're going to do then is take our negative 2 and plug it back into our equation. I'll plug it into the first one, so we get negative 2 plus 7y equals 12. We're going to add 2, and we get 7y equals 14. Divide by 7. Y equals 2. So our solution then would be negative 2, 2. X is negative 2, y was 2. Alright, now this is solving systems using elimination, but now we're going to use multiplication. We are multiplying first. So what we need to do is we need to find anything that we could multiply to get the same number. So we can't multiply anything, or 6 by anything to get to 8. We can't multiply anything by 5 to get to 7. So what we're going to need to do is multiply both of our equations. We're going to try to find the LCM, or the lowest common multiple. So I'll get rid of my x's. So I'm going to try to figure out something that I can multiply by 8 and 6 to get to the lowest common multiple. Now I know that 8 and 6, both of those, the lowest common that both of those go into is 24. So I'm going to multiply both of our equations by something to get to 24x. What we need to get 8 to 24, we have to multiply by 3. How we get 6 to 24, we have to multiply by 4. So 3 times 8x gives us 24x. 3 times a negative 7 gives us negative 21y. And 3 times negative 3 equals a negative 9. Now 4 times 6x gives us 24x. 4 times negative 5 is negative 20y. And 4 times negative 1 gives us a negative 4. So now we need to add or subtract to get rid of our 24x's. They're both positive, so I'm going to subtract 24. So 24 minus 24 eliminates. Negative 21 minus a negative 20. Both of those become positive, so it's negative 21 plus 20 becomes a negative 1y. Negative 9 minus a negative 4. Both of those become positive, so it's negative 9 plus 4, which gives us a negative 5. Then we divide by negative 1, and y equals 5. Then we put that 5 back into one of our equations. So 6x minus 5 times 5 equals a negative 1. So 6x minus 25 equals 1. If we add 25 then, well, this becomes a negative 1, sorry. We add 25, we'll get 6x equals 24. Divide by 6, and x equals 4. So our solution, x equals 4, y equals 5. Our solution is 4, 5. Next one, I'm going to subtract this 5y, get that over underneath the 7y. So we get 3x minus 5y equals a negative 7. Now we have our numbers lined up. Now, I can't multiply 3 by anything to get to 4. I can't multiply 5 by anything to get to 7. So I'm going to multiply and find the lowest common multiple. If I get rid of my x's, I know that 12 is my lowest common between the 4 and the 3. So to get from negative 4 to 12, I'm going to multiply this by 3. To get from 3 to 12, I'm going to multiply it by 4. So we get negative 12x plus 21y equals 24. 4 times 3x gives us 12x. 4 times negative 5 is negative 20y. And 4 times negative 7 is negative 28. So now I have two 12s, and I can add these two systems, so I'll add these two equations to eliminate my x's. So now we have 21 plus a negative 20, which gives us a 1y, and 24 plus negative 28, which gives us negative 4. So y is going to equal negative 4. Now if we take that negative 4 and plug it back in, we could have negative 4x plus 7 times a negative 4 equals 8. So negative 4x minus 28 equals 8. If we add 28 here, we'll get negative 4x equals 36. Then dividing that by negative 4, our x equals a negative 9. So our solution then will be x equals negative 9 and y equals negative 4. So negative 9, negative 4 is our solution. Alright, now we have a word problem. It says you pay $24.50 for 10 gallons of gas and 1 quart of oil at a gas station. Your friend pays $22 for 8 gallons of the same gasoline and 2 quarts of the same oil. Find the cost of 1 quart of oil. Okay, so we know that you pay for 10 gallons of gas. So we'll say 10G for 10 gallons of gas. And then you pay for 1 quart of oil. So we'll say 1Q. And that equals $24.50. Your friend pays for 8 gallons of gas and 2 quarts of oil, and he pays $22. So what we need to do is we need to eliminate something. Now we are eliminating something so we can find the cost of 1 quart of oil. So we're going to try to eliminate our gallons. Now, I can't multiply 8 by anything to get to 10, but I can multiply something so I can get the LCM. The LCM, I think, in 10 and 8 is 40, so I'm going to multiply by 4 for my 10, and I'm going to multiply 5 for my 8. So we'll get 40G for 40 gallons of gas plus 4Q equals 24.5 times 4, which equals 98. Then 8 times 5 is 40G, plus 5 times 2 is 10Q, and 22 times 5, that equals 110. So if I'm going to subtract these two systems, that would get rid of my 40Gs. So 4 minus 10 gives me a negative 6Q. 98 minus 110, that gives me a negative 12. I divide by negative 6. 1 quart of oil is going to cost $2. 1 quart equals $2. Next, we need to tell whether the system has one solution, no solution, or infinitely many solutions. So, we can take this 10x minus 2y and the 15x minus 3y. So, what we're going to do is try to eliminate something. Now, I know that my lowest common multiple between, it's going to be really hard to find between 10 and 15. That'd be a big number. But I know I can find one between 2 and 3. That's going to be 6. So what I'm going to do is try to get to 6 and eliminate my y's. So how do I get from negative 2 to 6? Well, I'm going to multiply by 3. From negative 3 to 6, I'm going to multiply by 2. So 3 times 10 is going to be 30x. 3 times negative 2 is negative 6y. And 3 times 14, give me 42. 2 times 15x is going to give me 30x. 3 times negative 3 is negative 6y. And 2 times 21 is going to be 42. So we're going to try to eliminate these. If we subtract them, 30 minus 30 gives me 0, that eliminates. Negative 6 minus negative 6, that eliminates. So we'll get 0 on this side, equals 42 minus 42, which is 0. That eliminates. So what we're left with is 0 equals 0. Well, that's true, 0 does equal 0. So the number of solutions for this problem is IMS, or infinitely many solutions. Next one over here, I see that I have 2 3x's and 2 4y's. What I'm going to do is I'm going to subtract. So I'm going to get rid of these 3x's, so 3x minus 3x eliminates. Negative 4 minus 4, that's going to give us a negative 8y. And 24 minus 24 is going to give me 0. Now, if I divide this by negative 8, my y is going to equal 0. So I know that I could plug that 0 back into one of my equations and get x. So what this is telling me is that this is going to be one solution. There's going to be an x and a y for this problem. So it's one solution. Next one is another word problem. It says one admission to a roller skating rink costs X dollars and renting a pair of skates costs Y dollars. A group pays $243 for admission for 36 people and 21 skate rentals. Another group pays $81 for admission and for 12 people and 7 skate rentals. How much is the cost of one admission to the roller skating rink? Well, if we take a look at this first group, they're paying $243 for admission for 36 people. We say that the one admission costs X dollars, so 36 times X, plus 21, and the rentals cost Y dollars, so 21Y. Another group is paying 81, and they're doing 12 people, so 12x, plus 7y, and we need to solve this problem. So, I see that I can eliminate by multiplying this bottom equation by 3. So what we're going to have then is 243 equals 36x plus 21y. 81 times 3 gives me 243 plus equals 36x plus 21y. Now if I subtract these all, this is going to eliminate, that will eliminate, and that will eliminate. So 0 equals 0. What this word problem is telling me is there's not enough information to figure this out. We can't figure out how much it costs for one admission to the roller skating rink just given these numbers. Here we're going to graph this system of inequalities. So how we're going to graph, we need to create a line in y equals mx plus b. So our first equation, we need to move the x over, or not equation, inequality. If we move the x over to the other side, we have to subtract it. So for the first one, we get y is less than or equal to negative x plus 10. So we start that line at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way at the top. And that's going down 1 and over 1. So we have a line that goes straight down at a diagonal. Now this is a less than or equal to, so less than or equal to or greater than or equal to, we need a solid line. So we can make a solid line straight through these points. Second inequality, we need to move the x again, so we have to subtract x. So we get negative y is greater than or equal to negative x minus 2. Then we divide by negative 1. And we get y. Now when we divide by a negative number, we have to flip our sign. So it becomes less than or equal to 1x plus 2. This one we start at 2, and we're going up 1 over 1 this time. Again, we have another solid line. And then our third inequality is just y is greater than 2. So we know that our y, or where are we going to begin, is 2. And we know that it's never going to cross the x-axis, so it's just a straight line through 2 on the y-axis, and it looks like that. Now, we need to test these. So what we're going to do is we're going to find a point that's not on the line, and we're going to test it to see if it's true. Now 0, 0 is not on my first line. So I'm going to put in 0 is less than or equal to negative 0 plus 10. Now I can't have a negative 0, so it's 0 is less than or equal to 10. That is true. So what I'm going to do is go to the side that 0, 0 is on, which is this side of my line, and I'm going to draw in some lines or shade in this side of my line. The second inequality, 0, 0 is still not a part of that line, so we can test 0, 0. So 0 is less than or equal to 1 times 0, plus 2. 1 times 0 is 0, so 0 is less than or equal to 2. That is true. So I can take this wherever 0, 0 is and shade in that side of my second line. And finally, the last one, that line is also not touching 0, so we look at 0 is greater than or equal to 2. That is not true, that is false. 0 is less than 2, not greater than 2. So we look at our third line, our line that's going horizontally, and we shade up where 0 is not. Now, the section where all of our lines meet is this triangle right here. So in this triangle are the only points that would work in all of our inequalities. This is our solution to this system of inequalities. Last problem. It says, in a marching band competition, score is based on a musical evaluation and a visual evaluation. The musical evaluation score cannot exceed 60 points. The visual evaluation score cannot exceed 40 points. Write and graph a system of inequalities for the scores that a marching band can receive. Well, if we say that our musical evaluation is X and our visual evaluation is Y, we know that our musical evaluation X has to be less than or equal to 60. It cannot exceed that 60. The visual, our Y, cannot exceed 40, so it has to be less than or equal to 40. So if we were to create one of our graphs here, the x-axis has to go at least to 60, so we could go up by 10, so 10, 20, 30, 40, 50, and 60. Go 70 for good measure. And our y has to go at least 40, so we could still go up by 10, 20, 30, 40, 50, 60, and 70. Our x has to be less than or equal to 60, so we know it goes at 60 on our x-axis. That's going to be a solid line straight up because it never touches our y. The y is at 40, and that's going to be a solid line that's never going to touch our x. So if we test these to see where they could cross, 0, 0 is not a part of any of them. So we could test x is less than or equal to 60 by putting 0. 0 is less than 60, which is true. So we could shade in all of this area of our first line. Then we could test if 0 is less than or equal to 40, and that's true. So we can shade in where our 0 is on this line, which is down. So it looks like the score that these bands can receive is in this section where our lines or our shading intersects. So they could receive a score of anything in this area here. They could not go past here or here. Alright, that is it for our review. make sure you are ready for your test coming up.